In this lecture, we are going to discuss about the rules for block diagram reduction. We have already studied about the block diagram in previous lecture, but let me summarize that here. As we know that if we are having a simple system, we can directly determine its transfer function. But whenever we are having a complex system which consists of number of elements, in that case, determining transfer function is not a simple task. So in that case, what we can do, we can find the individual elements transfer function and we can write them in block. And later on, all the transfer function which we have written in the block are connected in their logical sequence so that they represent actual system. So when we provide input to the actual system, we get output. The same kind of response we also expect from the block diagram. So that's why it is important to connect all the block diagram in a logical sequence. So once we are having block diagram of a given system, by applying these rules which we are going to discuss now, we can reduce it to a single block, and that single block will be having the transfer function, that is the transfer function of entire system. So let's start and discuss about the different rules that we can use to reduce block diagram. So we'll start with the first one. The first rule is the associative law. It says that when we are having summing points next to each other, we can interchange them. So once we interchange them, it is not going to affect the output of the system. Let's understand that. So here we are having two summing point next to each other. Suppose this is the input that is coming to the summing point and we are having input as R1. Then another input that is coming to this summing point, say it is R2. And the signal that we are having, it is a positive signal and R2 is also a positive signal. Similarly, the next summing point is having an input, say it is R3 and it is having a negative signal. So what will be the output here? Now let's find the output after each summing point. So once we consider this summing point, the output at this end will be R1 plus R2. So whatever signal is coming to a summing point, it will be added up. So here we will be having R1 plus R2 as the output after first summing point. Now this output will become input to this second summing point, which is having an additional signal in the form of R3, but it is a negative signal. So the output after this second summing point will be again addition of all the signals. So it will be R1 plus R2 minus R3. Now let's see if we interchange these summing point, whether we are going to get the same result or not. So again, here we are having an equivalent and let's see what we are going to get. So again, the incoming signal is R1 here, which is positive, and now signal we have changed. So here we will be having R3, that is negative signal, and at this second summing point we are having R2, which is a positive signal. So now the output after first summing point is R1 minus R3. Now after second summing point, it will be again addition of all the incoming signals. So it will be R1 plus R2 minus R3. Now here you can check that the output is same. So in both the case you are getting same output. So whenever you are trying to replace one thing with another in block diagram, it should give same output. So here also we are getting the same output, that is C of S is equal to R1 plus R2 minus R3. So this is the associative law, which state that if you are having two summing point next to each other, you can interchange them and that is not going to affect your output. You will be having same output. Now the thing that you have to always keep in mind is the summing point that you are considering, they should be next to each other. We should not have any block in between or any takeoff point in between. Otherwise you cannot use this rule. So in order to use this associative law, the summing point need to be next to each other. This is what a very important thing that you have to keep in mind. Now next rule we are having is block in series. This rule says that when we are having number of blocks in series, we can represent all those blocks, or we can replace all those blocks with a single block that will be having a equivalent transfer function, which will be a multiplication of all those blocks. Now let's understand that suppose we are having three blocks connected in series. Say block number 1 is G1, block number 2 is G2, block number 3 is G3, and we are having an input signal as say R of S and output as C of S. Now this block in series can be replaced by a single block which will be having transfer function equivalent to multiplication of all these three blocks. So here transfer function of this equivalent block will be G1 into G2 into G3, and it will be having same input and same output. Now let's try to understand how this is same, because when you are replacing one thing with another, it need to give same output. So let's try to understand. Now suppose this is the input R of S and it goes through G1. So output at this end will be R of S into G1. So whenever a signal passes through a block, the signal will get multiplied with that block or the transfer function of that block. Now this is an output here at this end and it will become input for G2. So output at this end we will be having R of S into G1 into G2. Similarly, after G3 we will be having output which we generally represent as C of S, and that will be R of S into G1 into G2 into G3. So this is the output that we are going to receive, and this we can write in the form of transfer function as C of S is equal to R of S is equal to G1 into G2 into G3. So this is the transfer function that we got from these three blocks. Similarly, if we determine transfer function for this, it will be C of S is equal to R of S, and we will be having G1 into G2 into G3. So in both the case, the output or the transfer function that you are getting is same. That's why we can replace the number of blocks connected in series with a equivalent single block, and that will be having transfer function as multiplication of all the transfer function of the blocks. Now again we have to be careful here that all blocks need to be next to each other. We should not have any summing point or any takeoff point in between. Next is rule number 3, blocks in parallel. So when we are having number of blocks in parallel, we can replace them by a single block, and that single block will be having equivalent transfer function. To get that equivalent transfer function, we need to algebraically add the transfer function of all the blocks in parallel. Now let's see that if we are having say block G1, G2 and G3 in parallel, and say input R of S we are having and output we are having as C of S. Now consider that the signal that is coming from G1 is positive, from G2 is negative, from G3 is positive. So here sign is very important, because based on the type of signal we are having, if it is positive it will be added up, if it is negative it will be subtracted. Now these block in parallel we can replace by a single block which will be having equivalent transfer function. So it will be having transfer function as G1 minus G2 and plus G3, and of course it will be having input as R of S and output as C of S. Now let's see how the transfer function for both these cases are same. Now if you consider here the input R of S, it is going through G1, G2 and G3, and then that signal is coming to this summing point and gets added up. So if we want to know what is the signal at this point after G1, so it will be input, that is R of S into G1. Similarly, signal after G2 block will be R of S into G2, and similarly we will be having after G3 as R of S into G3. Now all these signals will be added up at the summing point, and we will be getting C of S as R of S into G1. Then second signal, that is R of S into G2, is negative, so it will be minus R of S into G2. And then third signal we are having as positive, so it will be R of S into G3. Now from this equation we can take out R of S common, things left inside the bracket will be G1 minus G2 plus G3. And if we write this in terms of a transfer function, so it will become C of S upon R of S, that is output upon input, and we will be having transfer function as G1 minus G2 plus G3. Similarly, if we find transfer function for this equivalent block, so it will be C of S upon R of S, that is output upon input, and it will be G1 minus G2 plus G3. So we can see here for both the case transfer function is same. So we can replace a number of blocks in parallel with a single equivalent block. Next rule we are having rule number 4, that is shifting a summing point behind the block. So when we are shifting a summing point behind the block, the reciprocal of that block is to be added in series with the feedback signal. Let's understand this. So we are having a block G, and next to that we are having a summing point. So input to this is R of S, output is C of S, and we are having a feedback signal coming to the summing point as Y. It is a positive signal. Now when we want to find a value of a C of S here or output here, so we need to first get what is the signal that we are having after this block G. So it will be R of S into G, and the signal after this summing point will be C of S. So that C of S will be addition of these two values, R of S into G plus Y signal. So it will be R of S into G plus Y. So this is the output. Now when we apply this rule, that is shifting this summing point behind this block, we have to add reciprocal of this block in this feedback signal. So it is 1 by G, reciprocal of that block, and we are having block here G, and summing point we have shifted back of this block, so that is here. So input will be R of S as it is, we will be having C of S as output, and this is the Y signal, that is a feedback signal. So now let's find what is the output here. The signal after this summing point will be addition of this input signal and this feedback signal. So here this feedback signal will be Y into 1 by G, so it will be Y by G here. So this signal will be added up with this input signal, and we will be having signal after summing point as R of S plus Y of G. Now this signal will go through this block, and it will be multiplied with it. So we will be having an output as R of S plus Y by G into this block transfer function value. If you multiply G inside, so it will be R of S into G plus Y of G into this transfer function. So this G and G will get cancelled, and we will be having output as R of S into G plus Y, and it is same as this output. So this proves this rule. Next rule we are having shifting a summing point beyond or after the block. So when we shift summing point beyond or after the block, then we need to add that block in series with the feedback signal. Now let's understand this one. So we are having a summing point here, and we are having a block as G. So we want to shift this summing point after this block. Now let's find what will be output here. So input is R of S, feedback signal we are having Y, say it is positive feedback signal, and then we are having output as C of S. Now to get the output, we need to first find what is the signal after the summing point. So signal after this summing point will be addition of input and this feedback signal. So it will be R of S plus Y. Now this R of S plus Y will go through this block and will be multiplied by its transfer function. So that will going to give us output. So output will be R of S plus Y into G. So this is the output here. Now let's apply this rule and shift this summing point after this block. So to apply this rule, we need to add same transfer function of the block in the feedback signal. So that will be added here, G. So this is the feedback signal Y, and it is positive. So here we are having input as R of S, and output will be C of S. Now let's find what is the output for this condition. So signal after this block will be R of S, that is input, into the transfer function of this block. Then this feedback signal will be multiplied with this block transfer function, and we will be having feedback signal here at the summing point G into Y. Now these two signals, this one and R of S into G, will be added up at the summing point and will going to give us the output. So it will be R of S into G plus G into Y. What we can do here, we can take G common, so it will be R of S plus Y into G. So again we can see here the output for both the condition is same. Now let's discuss rule number 6, that is shifting a takeoff point behind the block. So whenever we are shifting a takeoff point behind the block, so same block we need to add in series with the feedback signal. So let's understand this rule here. We are having a block with transfer function as G, and it is having input R of S, output is C of S, and we are having a takeoff point through which a signal is emerging, and that signal we say it is Y. Now let's find what is the value of Y here and what is the value of output here. The signal after this block will be multiplication of this input and this transfer function, so it will be R of S into G, and now this same signal will going to give us the output. So here the output will become this value R of S into G, and the same output value we will be having for Y also, because it is again a point which is sensing this line C of S, output line, so it will be R of S into G. Now when we apply this rule, shifting takeoff point behind the block, so here we have to add the same block transfer function in the feedback signal, so it will be G here. We will be having again input same R of S, and output will be C of S, and the transfer function of the block is G. What we did, we are trying to shift this takeoff point behind this block, so because of that we are adding the same block here in series with the feedback signal. Now let's see what is the feedback signal value and the output here. So R of S is going to multiply with G to give us the output directly, so it will be R of S into G, and to get Y, this R of S will be multiplied with G, so again we will be having R of S into G as the value of Y. So we can see here the output value for both the case, and Y value, Y signal is also same, so this proves this result. Next rule is rule number 7, shifting a takeoff point beyond or after the block. So when we are shifting a takeoff point beyond the block, the reciprocal of that block need to be added in series with the feedback signal. Now let's understand this rule. So we are having a block G, and the input signal to that block is R of S, and we are having a takeoff point here that is giving us signal Y, and the output for this is C of S. Now let's find what is the output here and what is the value of this takeoff signal Y. So C of S will be R of S into this block, so it will be R of S into G, and the feedback signal, that is Y, will be R of S only. Now when we apply this rule, we need to add reciprocal of the block G with this feedback signal which is emerging from this takeoff point, so that is 1 by G. And now let's find what is the value of this feedback signal Y and output signal. So input is R of S. Now if we want to find what is the value of signal after this block, it is R of S into G, so output will be R of S into G. Now let's see the feedback signal here. So before this block, the value of a feedback signal is same as this value, that is R of S into G, and after this block it will be Y, so this value will be R of S into G into this 1 by G, that is a block value, so Y will become R of S only. because G and G will get cancelled. So now we can see here it is same as the value Y, and output also for both the case is same. Next tool is removing minor feedback loop. So whenever we are having a minor feedback loop, we can replace it by its closed loop transfer function. Now let's see how minor feedback loop look like. So it will be having a block transfer function. So say it is G of S, and it will be having a feedback signal, and it will be having its own transfer function as H of S. It will be having input R of S and output as C of S. So this is how minor feedback loop will look like. Now we can replace this minor feedback loop using its closed loop transfer function, that is given by G of S upon 1 minus plus G of S into H of S with same input and output R of S and C of S. Now let's see how we can derive from this minor feedback loop this closed loop transfer function. So for that we need to consider few things here, like this feedback signal. See, before coming to this point, this summing point, this signal is B of S, and say the signal is positive or maybe it is negative. Similarly, when the signal will go to this summing point, it will be compared with the input signal and we will be having some error signal E of S, and it will go through this G of S and we will be getting the output, and that output will be sensed using this feedback signal. So this is how a minor feedback loop will look like. Now let's define some parameter here. So error signal, that is E of S, we can write as it is R of S plus minus B of S. So error signal we are going to get by comparing input signal and this B of S signal. Similarly, B of S we can write, or feedback signal we can write as output C of S into H of S, because this feedback signal is sensing this output C of S. So in that way we can write B of S is equal to C of S into H of S. Similarly, we can write the output in the form of error and the block transfer function. So C of S, if we want to write, it will be error signal, that is E of S into G of S. Now let's derive the closed loop transfer function based on these equation. So let's use this equation number 1, that is E of S is equal to R of S plus minus B of S. Now here we can substitute B of S value from this equation number 2. So this equation will become R of S plus minus B of S is what? C of S into H of S. So it is output into transfer function of feedback H of S. Now similarly, we can use this equation number 3 as E of S is equal to C of S upon G of S. What we did here, we have just sent this G of S in this denominator. Okay, so we are getting E of S is equal to C of S upon G of S. Now this we can substitute here in place of E of S, so it will become output C of S upon this G of S, and right hand side we will be writing as same R of S plus minus C of S into H of S. Now let's solve it further. So C of S we can write by multiplying this G of S on right hand side, so we will be having G of S into R of S plus minus G of S into C of S into H of S. So next what we can do, we can transfer, or we can send this entire part, this value towards left side with C of S. So it will be C of S. Now if it is positive, if we move to left hand side, it will become negative, and if it is negative, it will become positive. So we need to invert this sign here, so it will be negative and positive with G of S into C of S into h of s, and that will be equal to g of s into r of s. Now from this left hand side we can take out c of s, that is output, common. So it will be 1 minus plus g of s into h of s. Right hand side will be same as g of s into r of s. Here we will put in bracket. Now we can write this in terms of transfer function. So it will be output, that is c of s, upon this input we can take here in denominator. So on right hand side we will be having numerator as g of s, upon we will be sending this 1 minus plus g of s into h of s value in the denominator here on right hand side. So it will be 1 minus plus g of s into h of s. So this is our closed loop transfer function for this feedback loop, and that is what we are having here. We are replacing this entire feedback loop with this closed loop transfer function, because again if we are having a transfer function as this one, so if we write in normal standard form c of s upon r of s, so it will be g of s upon 1 minus plus g of s into h of s, and which is same as what we have just derived. Next rule is rule number 9, that is shifting takeoff point after a summing point. So this rule states that a new summing point is added along the feedback signal, and upcoming signal to the first summing point is inverted and added to newly added summing point. So let's understand this. We are having a summing point and a takeoff point next to each other, and we want to shift this takeoff point after this summing point. So we are having r of s as input and c of s as output here. Let's consider this takeoff signal as x, and we are having y signal at this summing point. So let's consider that y is maybe positive or negative. So let's find what is the value of x and output here. The value of x will be equal to the input signal value, so it will be same as r of s. Now to find what is the output value here, that is c of s, so we need to consider the signal after this summing point. So at this summing point, this input signal and this feedback signal y will get added up based on the sign of y. So the output signal will be addition of r of s and this y signal. So it will be r of s plus minus, so based on the sign of y. Now when we apply this rule, when we take this takeoff point after this summing point, so we need to additionally create a summing point where we need to add this y signal but in inverted form. So if we are having y signal as positive, it will become negative here. If it is negative, it will become positive here. So based on this rule, we need to do this thing. So here also input signal will be r of s and output signal will be c of s, and we will be having x here, which is having this additional summing point, and to this summing point we are having this signal, y signal is added up in inverted form. Now let's find what is value of x and what is value of output here. So to get the output, we need to know what is the signal after the summing point at this place. So it will be addition of input signal and this feedback signal y. So the output will be r of s plus or minus y. Now to get the value of x, we need to know what is the value of signal after this takeoff point over here. So it will be r of s plus minus y, that is the output signal. So now at this summing point, this output signal and this y in inverted form will get added up, and we will be having value of x. So to know what is the signal value here, we will be adding these two signals, r of s plus minus y and inverted form of y. So it will be minus and plus of y. So both y will get cancelled with each other, and we will be only left with r of s. So x value will be r of s. So here we can see that in both the case x value is same and also the output value is same. Next rule is rule number 10, shifting takeoff point before a summing point. So when we are using this rule, a new summing point is added up along the feedback signal, and upcoming signal to the first summing point is added up to newly added summing point. Let's understand this. So here we are having a takeoff point after the summing point, and we want to move this takeoff point before this summing point. So here also input is R of S and output is C of S. We are having this feedback signal going towards the summing point as Y, and this takeoff signal is X. Let's find what is the value of output here and what is the value of X here. So to get the output, we need to know what is the value of signal after the summing point. So it will be addition of these two signals, R of S and Y. So if it is positive, it will be added up. If it is negative, it will be subtracted. So output value will be R of S plus minus Y. So X will be also as R of S plus minus Y. Now let's see if we apply this rule, what is going to happen. So here we have shifted this takeoff point before this summing point. So we have added one more summing point, and we have also added to the summing point the signal Y. So input here is again R of S and output is C of S, and Y is having value maybe positive or negative, and the same we need to add here, positive or negative. And this is what X, where we have added a new summing point. So to get the output, we need to know what is the signal after this summing point. So it will be addition of these two signals, R of S and Y. We will be having output as R of S plus minus Y. Now to find X, we need to again see what is the signal that is coming before this summing point. So that signal is R of S here, and also we are having Y here in the form of positive or negative, same signal. So to get X, we need to add these two signals. So we'll be having R of S plus minus Y. So here we can see that both X is same and also output is same. So this proves rule number 10. Now one important thing, rule number 9 and rule number 10 are also called as critical rule, and generally we avoid using these rule in block diagram reduction, because what is happening here, we are additionally creating summing point and also we are creating additional signal here. So because of that, generally the block diagram will become more complex and solving it become difficult. So because of that, we avoid using rule number 9 and rule number 10. Now before ending this, let's revise first 8 important rule. So rule number 1 is associative law, which says that when we are having two summing point next to each other, so we can interchange and it is not going to affect the output. Next is rule number 2, blocks in series. So when we are having number of blocks connected in series, we can replace all those blocks with a single block, and it will be having equivalent transfer function, which we get by multiplying the transfer function of all the blocks. Next is rule number 3, blocks in parallel. So when we are having number